Welcome back. In this lecture, we will provide an overview of artificial neurons, a key component for building neural networks. So lesson objective, the whole idea is you should be able to describe an artificial neuron. And so let's start with an actual neuron, the inspiration for this mathematical structure we call an artificial neuron. And so a couple key things is the inputs, the dendrites of where it receives information. Computation occurs within the nucleus, and then output is sent through an axon. These components are replicated in the artificial neuron. And the other interesting thing about the biological neuron that inspires an artificial neuron is the fact that they can be networked together. So signals that go from the axon of one neuron can be received by dendrites of multiple other neurons. And this is how various tasks can then get accomplished. So let's introduce the artificial neuron, this major structure. So first we have the inputs that come from the previous layer of neurons, or maybe these come from, the original input to the system, and we'll number them x1 through xn. And oftentimes we will show this as a single capital letter X, which would specify a vector. Now, with each of these inputs, there will be an associated weight, W1 through Wn. And there will also be what's called a bias term. That is a weight, but it's not associated with any of the inputs. And this is something that, we even see in more simpler forms of machine learning like linear regression, where the bias just kind of moves where the function appears on the graph. Now the output, so the idea is all of the inputs get processed and turned into a single output value. And the major component to this is a weighted sum of the inputs, simply using the weights. But it's not linear. We apply what's called a nonlinearity or an activation function to that. And we will discuss activation functions further in a later lecture, but one thing just to give you a little bit of a preview, in general you want that activation function to be differentiable. So we will often group these artificial neurons into layers, and in general there will be an input layer that will receive information from the original input, whether it be text or images or some other perception from a robot, maybe LiDAR. Then there is the architecture of this will really determine the layout of the connections. So depending on what the network is designed to do, and in this course we will talk about several different types of architectures, such as convolutional neural networks that are often used for image processing, recurrent neural networks that get used for sequential data, as well as the more cutting-edge transformer architecture that has really been lately shown to be a lot of success with things like natural language understanding. And so that architecture, those connections in these inner layers that are processing the data, there could be a large number of them actually. The weights associated with the connections between layers are even sometimes shared, and that also is a key aspect of the architecture. There might even be what we'll talk about later on, kernels in convolutional neural networks, or recurrent neural units in RNNs. And you'll see that a key facet with those is that the weights get used in multiple connections. And finally, at the end, there's the output layer, and this is where the data is taken from the last few hidden layers and combined together in a way that addresses the problem at hand, whether it's regression or classification. What's really nice about the layered infrastructure is that tools like TensorFlow and PyTorch have made it really easy to specify a given layer by just talking about what type of layer it should be, the number of nodes in the layer, etc. And this has allowed for very easy building of highly complicated architectures. So that's it for this introductory lesson on artificial neurons. Stay tuned for more content.